Ever tried to implement a character movement in the latest version of Unity? Then you have found out that the old Input.GetAxis method is outdated. The new standard is the Input System Package. It's much more powerful. In this tutorial, we are switching to the modern approach. We will set up the input action for keyboard and implement the movement using character control and Rigidbody. Let's get your character moving the right way in the Unity 6. Before we dive into the setup, if you find this tutorial helpful, please hit the like button, share the video with the fellow developers, and subscribe for more Unity tutorials. Your support keeps this tutorial coming. You can also check out my Buy Me Coffee link in the description below if you want to support the channel further. Let's get into the tutorial. The first step is creating an input action asset. Right-click in your project, create, select input action. Name it player input action. Double-click the asset to open the editor window. We need hierarchy. Create an action map called player and an action map called move. Select move to change the action type to value and control type to vector 2. This tells Unity we want two directional value, perfect for movement. Now the bindings. Click the plus icon and choose Add Composite Vector. Assign your W, A, S and D key easily by clicking the path field and pressing the physical key on your keyboard. Let's add keys. For up, we use W from keyboard. For down, we will use S from keyboard. For left, we use A. And for right, we will use the D. We can quickly add another composite for arrow keys, like we do for our keyboard keys. Let's add arrow keys. For up arrow. For down arrow. And the left for left arrow. And right for right arrow. Click Save Asset at the top right. Then check Generate C# class and click Apply. Unity creates a C# script for us automatically, bridging the gap between your input mapping and your code. Now, let's move our character with the character controller. Select character and add character controller component in the character. We have already created a script called player movement. Add player movement script in the character. Assign a character control in the script and give the speed that you want to move your character. Let's open the script. We need a reference to our character control and a public speed variable. We can tweak in the inspector. We create reference for our generated player input action class and a vector 2 to store the input. In the await method, we initialize our input action. On enable and disable, we enable and disable the action map. If you forget to enable the map, nothing will work. In update, we have used the line input action.player.move.read value. This line reads the current state of our 2D vector input. We have defined two float variable x and z that reads x and z values from our 2D move input. We create a move vector using the character's local right and forward direction, ensuring movement is relative to where the character is facing. We then normalize it and multiply by our speed variable, and finally call the controller.move. Crucially, we multiply by time.delta. This ensures your character moves the same distance per second, regardless of the game's frame rate. Now, hit play, and you now have a modern, flexible input system that works with the keyboard keys. Let's quickly switch gears to the Rigidbody implementation. Remove player movement script and character control from the player. Add Rigidbody component. A quick pro tip: when using the Rigidbody for character, make sure to freeze the rotation constraint on the X, Y, and Z axis in the inspector. This prevents your character from tipping over like a ragdoll when it hits walls, giving you a smoother and more controlled movement. Also, for Rigidbody, we have created one script called Player Physics Movement. Add this in your character. Assign a Rigidbody and give appropriate speed to move your character. Now, let's jump into the script. We swap out character control reference for a Rigidbody reference. A key difference is that we move our logic from update to fixup, which runs at a consistent physics timestamp. Instead of controller.move, we use rigidbody.addForce with the movement vector multiplied by speed. This gives character that physical momentum-based feel. This method applies a continuous force to the object, letting the physics engine handle the actual position changes. The input setup is identical. We add our awake, on enable, and on disable methods, and we still use read values to get our input in the fix update. Now the setup is done. Hit play, and you will notice the movement has a bit more momentum. You have less direct control than with the character control, but you gain all benefits of Unity's built-in physics simulation. The new input system is modern, powerful way to handle inputs in Unity 6. So, which one should you use? The character controller is great for precise, snappy, non-physics based movement, perfect for most first-person or third-person action games. The Rigidbody is ideal when you need a physical interaction like pushing objects or dealing with the complex environmental forces. The complete code for both methods is available in the description below. If this tutorial helped you to upgrade your input system, don't forget to like, share, subscribe, and maybe even buy me a coffee. Happy coding, and I will see you in the next tutorial.